Chapter 4 Sewage Disposal System 1. The sewage and its disposal. The collection and safe disposal of human waste are among the most critical problems of environmental health. Recent statistical reports reveal that most of the waterborne diseases, such as dysentery, typhoid, diarrhea, and other intestinal disorders, are prevalent in areas where there is no proper and scientific sewage disposal system. It was reported that when human waste are deposited in a pit, typhoid and dysentery-causing organisms do not travel horizontally in the soil. These harmful bacteria neither move by themselves. They were carried in some way. These harmful organisms are carried somewhere through water flows, flies, rodent, cockroaches, and other vermin, which causes contamination. The daily average volume of human waste or excreta per capita is about 80 grams of feces and 950 grams of urine. When diluted with water at the rate of 30 to 100 gallons per day to form sewage, the solid content becomes a very small portion expressed in milligram per liters. Of the total sewage solid, about 50% is organic and are subject to rotting. Small as it is in the sewage, and as decomposition continues, it becomes odorous and dark in color. And whether fresh or stale, it contains harmful organisms that causes diseases. It is therefore important not only to know the different type of sewage disposal system, but also to understand the scientific value of the system. Type of sewage disposal system. Sewage disposal system has 4 types. 1. The cesspool. 2. The privy. 3. The septic tank. 4. The public sewer line. The cesspool is a hole in the ground, curved with stone, bricks, concrete hollow blocks, or other material laid in such a manner as to allow raw, contaminated sewage to leach in the soil. The organic waste accumulate and finally dispose of by disintegration process. Figure 4:1 shows cesspool. The privy is a concrete sealed vault with a wooden shelter constructed for the collection of raw sewage. That disintegration of excrement is accomplished in the same manner as in a cesspool. It is objectionable because of the danger of contaminating the source of water supply. Figure 4:2 shows the privy. The septic tank is a device or receptacle used to expedite the decomposition of the element contained in the raw sewage waste. Raw sewage consists of water and suitable solid called organic materials that can be precipitated in a septic tank in a very short time. The public sewer line is a public sewage system operated and maintained by the government, consisting of a sewage treatment plant that conveys the raw sewage from buildings and houses to a disposal system. Of these 4 types of sewage disposal, the cesspool and the privy are already obsolete. The prevailing type recommended by the sanitary authorities are the public sewer line and the septic tank. 2. Public sewer line. The public sewer line is classified into 3 types according to the kind of waste it disposes. 1. The combination public sewer. 2. The sanitary sewer. 3. The storm drain. The combination public sewer is the oldest type of public sewer that conveys both storm water and sanitary waste. This type of public sewer is already obsolete and no longer allowed by sanitary authorities. The sanitary sewer is a public sewer facility that carries regular sanitary waste only. It terminates in a modern sewage dispersal plant. Rainwater is not permitted to enter into this type of public sewer. The sanitary sewer is classified into two types. 1. The intercepting or trunk line sewer. 2. The tributary or contributing sewer. The intercepting sewer is a sanitary sewer that conveys sanitary waste to a dispersal plant. It is commonly made of concrete pipe that varies in size from 0.60 to 3 meters in diameter. The pipes are laid underground to a minimum depth of about 3 meters depending about the natural contour of the ground. Figure 4-3 shows the intercepting sewer. The tributary sewer is classified as an intercepting sewer branch. The pipe is made of either verified clay or concrete pipe laid in an open trench. It is generally smaller in diameter, installed not more than 3 meters below the street grade, and terminate into the intercepting sewer line. The storm drain is another kind of public sewer line that carries storm water. It terminates in a natural drain such as canal, lakes, or rivers. Manhole is classified as a device of the main and storm sewer. It serves as a man's access for inspection, clearing, and repair. It is constructed out of bricks, stones, adobe, or concrete at an interval distance from 70 to 150 meters. The manhole diameter varies from 90 to 120 centimeters, provided with iron rung to serve as ladder for the maintenance crew to reach the bottom. It is provided with a well-fitted cover on top, leveled with the road surface. Figure 4-4 shows manhole. The material required for the public sewer line could be determined under the following procedures. 1. From the plan of the public sewer line, find the net distance between manholes to be laid with concrete pipes. Total distance minus the space area occupied by the manhole. 2. The net distance found divided by the length of one pipe at 1 meter long regardless of its diameter. 3. Subtract 3% to 4% from the obtained number of the pipe in order to get the exact number required. Illustration 1. As shown in figure 4-5, determine the number of 60 cm diameter concrete pipe. Figure 4-5 shows manhole of public sewer line. Solution. 1. Find the net length to be laid with concrete pipe. The distance between station 1 and 2 is 100 meter. Subtract the space occupied by manhole, 1 meter. The net distance is equals to 99 meters. 2. Divide the net distance by the length of one pipe. 99 meter divided by 1 meter is equals to 99 pipes. 3. Subtract, say, 3% to get the exact number of pipe. 99 times 0.3 is equals to 2.97, says 3 meters. 99 minus 3 meters is equals to 96 pipes. 4. If there are 96 pipes, only 95 joints will be grouted or plastered, because the two ends will terminate at the manhole. 5. Refer to Table 1. Concrete pipes with 60 cm diameter needs 132 bags of cement and 0.0165 cubic meters sand per joints. Multiply. Cement, 95 times 0.132 is equals to 12.54 says 13 bags. Sand, 95 times 0.0165 is equals to 2 cubic meters. Comments. 1. To some estimator, the number of sewer pipe needed for a certain distance or station is found by dividing the distance by the length of one pipe. An allowance of 3% to 5% is also added for alleged contingencies. 2. The idea of dividing the distance by the length of one pipe is acceptable, but the additional 3% to 5% is questionable. It would be interesting to note that in actual installation of concrete pipe, the end joint cannot be fitted exactly with each other. A small gap between the pipe joints cannot be avoided because the material and installation are not precision made. 3. If the installation of the concrete pipe is done manually, handling of the material inside the deep excavation is so difficult to make a well-fitted joint. A gap of about 2 to 5 centimeters between the pipe joints cannot be avoided. However, it is usually corrected by means of concrete grout or plaster. 4. Assuming that the gap between pipe is about 3 centimeters and for additional distance of 100 meters between the manhole, there will be a total gap of 99 joints. Multiplied by 3 centimeters is equals to 297 centimeters or about 3 meters. 5. The gap of 3 meters long is subtracted from the net distance of 99 meters. The number of pipe required between manhole distance is only 96 pipe. On the other hand, if the distance between manhole is 100 meters divided by the length of one pipe, which is 1 meter plus additional 5% allowable, would mean a total of 105 pipes needed per station. With this manner of estimating, the additional 5% allowed for contingencies will only result to a bloated estimate. 7. Questions might be raised why the length of 99 meters per station was used instead of 100 meters. The distance indicated in the plan is measured from center to center of the manhole. Subtracting the space occupied by the manhole, the length to be laid with the pipe will only be 99 meters, not 100 meters. 8. The gap between pipe is a great significance in making estimate because it will materially affect the cost, especially when the installation calls for a longer distance in terms of kilometers. 9. The values given in Table 41 assume to complete the circumferential plaster joint of the pipe in accordance with the standard specifications. 10. For more detail on estimating, refer to the book Simplified Construction Estimate by Fajardo. Table 41 shows the quantity of cement and sand per pipe joints. The values presented was based on the assumption that the grout or plaster completely surrounds the joints between pipes. Sewage Ejector. Sewage ejector refers to the pump that will discharge waste in the sump and transfer it to the house drain installed overhead. Sewage ejector is necessary when the public sewer line was installed at a depth from 2 to 4 meters below the street level. Large building with basement may have been deeper excavation making it difficult to drain its waste toward the main sewer by means of gravity. 3. The septic tank. Septic tank is a receptacle or vault used to collect organic waste discharged from the house sewer. The main function of a septic tank is to liquefy and precipitate solid waste, purifying odorous materials. Sewage that was discharged into the tank is retained, and during its retention period, about 60% to 70% of the suspended solid of the sewage is removed largely by sedimentation to form a semi-liquid substance called sludge. The sludge accumulates at the bottom of the septic tank. Parts of the solid are formed into floating scum. Both the scum and the sludge are pressed by aerobic bacteria and transforming them into liquid and gases. This process is called digestion. The solid matter is reduced in sizes and consequently changed in character. The septic tank therefore combines two processes: sedimentation in the upper portion of the tank and aerobic decomposition of the accumulated sludge at the bottom. Decomposition of organic matter from human waste is bacteriological process caused by 1. Aerobic bacteria called aerobes. 2. Anaerobic bacteria called anaerobes. 3. Facultative bacteria. The life process of aerobic bacteria is in the presence of material oxygen. The anaerobic bacteria, on the other hand, function in the absence of free oxygen. Likewise, facultative bacteria also function even with or without free oxygen. These three types of bacteria have no relation to disease. They thrive naturally in sewage and will function when conditions are favorable in terms of 1. Food supply, 2. Temperature, 3. Moisture. However, even when conditions are favorable, this bacteria will cease to exist in the presence of antiseptics or disinfectants, and to discharge large amount of volume of waste and water containing disinfectant, oil and grease into the septic tank will affect and disturb bacterial activities therein and may then destroy the purpose of which the septic tank is constructed. The human waste or excreta are decomposed until the organic material are transformed into material that could no longer be utilized by the bacteria in their life process. The process of decomposition is regarded as stabilization. Decomposition caused by anaerobic bacteria, which is sometimes referred to as putrefaction, is accompanied by bad odors. On the other hand, aerobic decomposition is not accompanied by unpleasant odor. A sewage that turns dark and smells unpleasantly due to anaerobic decomposition is called septic. Decomposition caused by aerobic bacteria is accomplished with no defined time and could be within a matter of hours. Figure 46 shows the plan in section of septic tanks. Gases that are produced inside the septic tank. There are different gases produced inside the septic tank, ranging from organic to non-organic gases. These are 1. Methane gas, or CH4, is a combination of hydrogen and carbon dioxide. a principal component of natural gas. 2. Carbon dioxide, or CO2, is a combination of carbon and oxygen. It is the simplest oxide of carbon. 3. Carbon monoxide, or CO, is a byproduct of methane, classified as poisonous gas. 4. Hydrogen, or H2, involved as a moist gas from organic waste. 5. Hydrogen sulfide, or H2S, is a colorless gas with offensive odor. 6. Sulfur oxide, or HO2, is also a colorless gas having an irritating odor. These gases are discharged into the atmosphere through the ventilation pipe. 4. Construction of the septic tank. Septic tank is constructed from either of the following material. 1. Reinforced concrete. 2. Plastered concrete hollow block. 3. Prefabricated asbestos. 4. Thin metal and plastic. The most popular and wisely used material for construction of septic tank is plastered concrete hollow blocks or reinforced concrete. Others have not gained acceptance due to cost and durability. General condition in constructing a septic tank. 1. The concrete or masonry septic tank is usually constructed in a regular form. The reason it is to retard the even flow of the water that is necessary to avoid disturbing the decomposition process inside the tank. 2. The minimum inside dimension of a septic tank is 90 cm wide by 150 cm long. Figure 4 to 7 shows the minimum size of a septic tank. 3. For effective decomposition of the organic materials inside the septic tank, a 120 cm depth of solid content is necessary. It is not impractical, though, to construct a tank of greater depth, provided that the depth should not be deeper than the natural ground water table. 4. The inlet and outlet inverts of the septic tank shall be long-term sanitary T. The invert are installed into the wall of the tank at least 120 cm from the bottom floor, equally spaced from both sides. 5. The invert is extended down to the liquid of the tank not more than 30 cm. This is to assume smooth delivery of the incoming sewage below the scum line. Scum refers to the lighter organism materials that rises to the surface of the water. 6. The bottom of the digestion chamber should be sloped to one low point. The purpose is to gather the settled organic material into one mass to favor the propagation of the anaerobic bacteria. 7. The septic tank should be provided with a manhole extended a few centimeters above the surface of the soil to overcome infiltration or surface water. This manhole will serve the purpose of cleaning, inspection, and repair of the tank. Figure 4 to 8 shows the single chamber septic tank. 8. Septic tank for larger plumbing installations are provided with suspended compartment attached to the ceiling slab of the tank. The baffled plate is extended down to the bottom of the tank, about 40 centimeters below the scum line. Each compartment of the tank, separated by baffled plate, is provided with manhole. 9. The septic tank should be constructed near the surface of the ground. Because of the correction of the waste depends upon the extent of oxidation and the existence of anaerobic bacteria, another kind of bacteria that is split and digest the effluent is the aerobic bacteria, a kind of bacteria that survive only in the subsoil not more than 150 cm below the surface. Oxidation of the effluent deeper than 150 cm would become extremely difficult. 5. Size of the septic tank. So far, there is no mathematic formula ever formulated to arrive in determining a definite size of a septic tank. However, sanitary authorities agreed in principles that 1. For a family of 6 persons, the minimum tank capacity should be approximately 1.3 cubic meters with a minimum size of 90 cm wide by 150 cm long and 120 cm depth. 2. A very large tank is not advisable because the bacterial activities would be retarded. The size of the tank is proportionally based on the number of persons expected to be served. In other words, the volume of the tank has a rational proportion with the volume of incoming waste for bacterial activities to be in favorable condition. 3. For residential installation, the practice is to allow 5 to 6 cubic feet of tank volume per person. Thus, a septic tank that will serve a family of 12 persons must have the liquid capacity of 6 by 12 equals to 72 cubic feet or 538 gallons. 1 cubic foot is 748 gallons. Technical data in determining volume of septic tank. Minimum width is equals to 90 cm. Minimum length is equals to 150 cm. Minimum depth is equals to 100 cm. For residential building to serve larger number of people, allocate 0.14 to 0.17 cubic meter of liquid per person. For small residential house to serve up to 12 persons, the chamber should have a liquid content of not more than 2 cubic meters. For school, commercial, and industrial establishment, the volume of septic tank should not be less than 0.057 cubic meter nor more than 0.086 cubic meter per person. Where a large amount of wastewater is coming from shower bath, laundry, and others, it is not advisable to permit entry of this water into the septic tank. Likewise, all downspout collecting water from the roof should not be allowed to terminate into the septic tank. Rainwater should be conveyed to storm drain. Illustration 2. Determine the size of a septic tank to serve 200 persons in a commercial establishment. Solution. 1. To determine the volume of a septic tank, refer to the technical data of information, page 92. For a commercial establishment, we find the value of 0.057 cubic meters. Multiply 200% times 0.057 is equals to 11.4 cubic meters. 2. Assume 1.2 meters width of the tank per 100 persons. For 200 individuals, multiply 200 times 1.2 is equals to 2.4 meters width. 3. The maximum depth of a septic tank liquid is 1.5 meters. Solve for the length of the septic tank. Length times width times depth equals volume. Length is equals to volume divided by width times depth. Length is equals to 11.4 divided by 2.4 times 1.5. Length is equals to 3.2 meters. 4. The value of L is only for the length of the digestion chamber. Divide by 2, then add result to the value of L to include the leaching well. L divided by 2 plus L is equals to 3.2 divided by 2 plus 3.2. Total length is equals to 4.8 meters. Therefore, the size of the septic tank to serve 200 persons is 2.4 meter wide by 4.8 meters long. Figure 4 to 9 shows the cross-section of septic tank of illustration 2. Illustration 3. A motel with toilet and bath and kitchen facilities will serve a maximum of 100 persons. Determine the capacity and dimension of the septic tank. Solution 1. Refer to Table 4 to 2. Under motel with bath, toilet, and kitchen, the waste per person per day is 50 gallons multiplied by 100 person is 5,000 gallons a day. 2. Using the formula V is equals to 1.125 plus 0.75 Q, where V is equals to liquid volume of the tank in gallon and Q is equals to the daily sewage flow in gallons. 1.125 and 0.75 is constant value. 3. Substitute. V is equals to 1.125 plus 0.75 times 5,000 gallons is equals to 3,751 gallons. 4. There are 264 gallons in 1 cubic meter volume. Divide 3,751 divided by 264 is equals to 14.2 cubic meters capacity of the septic tank. Table 4-2 shows the quantity of sewage flow, where it shows the type of establishment and the gallons per person per day. Source: Manual of Septic Tank Practice, Public Health Services, Publication 526. 5. To find the dimension of the septic tank, if the maximum depth is 1.5 meters and the width is assumed to be 3 meters, divide. L is equals to 14.2 cubic meter divided by 3 times 1.5 meters is equals to 3.5 meters. Table 4-3 shows the suggested size of septic tank for residential and commercial or industrial. Table 4-4 shows the maximum allowable sludge accumulation in a septic tank. 6. Location of septic tank. location of the septic tank shall observe the following consideration. 1. The septic tank may be located closer to the building it will serve, providing a minimum distance of 2 meters from the outside wall. 2. As much as possible, the septic tank should not be located closer to the door or windows. 3. Septic tank should be at least 15 meters away from any source of water supply. The farther, the better. Requirement for a satisfactory disposal of human waste. 1. There should be no contamination of ground surface that may enter into the spring or wells. 2. There should be no contamination of surface water. 3. The surface soil should not be contaminated. 4. Excreta should not be accessible to animal, flies, cockroaches, vermin, and the like. 5. There should be no odor or unsightly conditions. 6. The method used should be simple and economical in terms of construction operation. 7. Safety precautions. In most cases, septic tanks are poorly aerated or ventilated. It lacks free oxygen. Under this condition, an individual entering into a septic tank for making repair or cleaning purposes may meet almost instant death. Septic tank may contain harmful and dangerous gases. When repair work or cleaning is to be made, be sure that septic tank is well ventilated by removing the manhole cover few days in advance of the work. Another precaution is to supply fresh air inside the tank while work is being done. Remember that the tank may contain inflammable gases that might be ignited to cause a terrible explosion. If light is needed to work in the dark, an electric emergency light with properly insulated cord should be used. In the absence of electric supply, a flashlight powered by dry cell battery is equally safe. 8. Sewage treatment. The effluent removed from the septic tank is still in the stage of objectionable matter. Although these organic matters have been removed and many of the objectionable gases have been eliminated, still it contains countless number of harmful anaerobic bacteria and objectionable chemical compound in solution that must be disposed of. There are several methods and processes wherein sewage may be treated, and those that are most commonly used are the activated sludge process and the trickling or sprinkling filter process. The detailed scientific analysis of sewage treatment is beyond the scope of the subject and plumbing, but in passing, it is worth mentioning that the treatment of municipal sewage is a complex problem involving scientific aspect outside the sphere of plumbing. The design and construction of a modern sewage disposal plant requires engineering training in all phases of natural science. Civil work for the design and construction of the structure. Mechanical for the construction of equipment, plus an extended knowledge of chemistry, physics, and bacteriology. End of Chapter 4.